Okay, so we're gonna carry on with salts qualitative analysis. So for salts qualitative analysis, I think it's very important for us to take note that what we are trying to do is to test. Okay, it is really like a test. When you do qualitative analysis, we're trying to test. Okay, what are the ions present? We're trying to test for the ions. Okay, so in the midst of this testing for the ions, there are some other things that you need to take note of. And what are they? We're going to go through them. Okay, so let's read through. Some soluble ions, such as the heavy metal cations, can be harmful if swallowed. So how do we make sure water is safe? Okay, we can actually identify the dissolved cations, the dissolved anions. So take note, when we do qualitative analysis, we're actually looking at the soluble cations and ions. Okay, so how do we identify them? Okay, we add certain reagents. So we must add something to it. Then we observe. So add something, we see what's the change. Okay, to really find out whether there is or there isn't that particular cat or anion. So this process of identifying cat and anions, we call it qualitative analysis. So it's very important for us to be mindful what we are adding. If we know what we are adding, and we know what we are trying to test, whether is it the anion or the cation, we will be able to determine what is the cation and anion present. Okay, so let's start with the first one. Now for salts, I hope you are able to know that this is on the chapter of salts. Okay, salts would typically contain a cation, which is the positive ion, and it will contain an anion, which is the negative ion. Okay, so we will do tests to find out what's the cation, what's the anion. And if we know what's the cation, we know what's the anion, we will be able to find out what is the particular salt. Okay, now, so let's start step by step. The first part we're going to learn is how to identify the cation. How? So to identify cations, we are going to use a reagent. What reagent is it? It's going to be sodium hydroxide solution, or sometimes they will call it aqueous sodium hydroxide. And we're also going to use aqueous ammonia. Okay, so we got aqueous sodium hydroxide, which is NaOH aqueous. We also have aqueous ammonia, which is NH3 aqueous. So take note, these are the two reagents, 1, 2, used to identify cations. Okay, now how to identify the cations is really because all the cations will give precipitate with these alkalis. Okay, now, so take note, I want to highlight this point, really important. Sodium hydroxide and aqueous ammonia, they are alkalis. Okay, these two are alkalis. The cations will form precipitates with the alkalis. Okay, when we say precipitate, they are actually referring to solids. So the cations actually form solids with this alkali. Okay, so what are the things we need to take note about this precipitate here? First thing, the cations can be identified by noting the color of the precipitate. So the color of the precipitate tells us what is the particular cation present. Okay. Second thing, it's not just about the color. We will also find out whether the precipitate is soluble or insoluble in excess of the reagent. That means excess of the reagent means you add a lot more. So typically in the reaction, we will add a few drops first. We will do drop by drops, okay, to see the precipitate. After that, we will add in excess. So these are the steps we'll actually be doing, okay, to test for the cation. We'll add a few drops, observe what is the color of the precipitate. Then we add in excess to see whether it is soluble or insoluble. And lastly, okay, this one, once in a while may come out, we will really check whether ammonia gas is liberated, okay, on the addition of sodium hydroxide. Typically, we will always look at 0.1 and 0.2. Point 3 is the one where you're going to observe sometimes. Okay, you're going to see it happens sometimes. Okay, so but 1 and 2 is definitely the most important one. Okay, now I want us to take note of this box over here. Okay, so sometimes when we do cation tests, okay, there's really no change that we have observed. So when there's no precipitate produced, there's no gas liberated, we may say that there is no visible change that's observed. Right? No visible change is observed. So take note of the phrasing because you will need to use this for your practical. So no visible change observed, okay, is one way to highlight that, yeah, there's nothing really being seen there. No precipitate is formed, okay, no gas is produced. Okay, so take note, no visible change is observed. Okay, so question is, Chala, you tell me you can add these two, but then, what exactly are we looking out for? How do we differentiate between all the various cations? So first thing, you need to know only these few cations. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 cations that you must be very clear on how to differentiate between them. Okay, can you see on top here? Okay, this is the first reagent. When I add sodium hydroxide, what are the things that's going to happen? When I add aqueous ammonia, this is a second possible reagent that I can use. Okay, what is going to happen? So first thing, let's split it up. Okay, so amongst these few, I just want to take note. Let's group zinc, lead, and calcium together. These three, we group them together. The second cluster we're going to group together is copper, iron 2 and iron 3. And the last one will be ammonium on its own. Okay, why do I have this classification? So I want you to see here, sodium hydroxide. When you add a few drops initially, what happens? Zinc, lead, and calcium, all of them will form a white precipitate. All of them will form a white precipitate. That's why you realize I grouped the three of them all together because they all form white precipitate. After adding a few drops, I now add excess. That means I add a lot more of it. You realize the difference is over here. Zinc will dissolve in excess to form a colorless solution. Lead will also dissolve in excess to form a colorless solution. However, calcium, the precipitate is insoluble in excess. That means you can add in excess, okay, you add a lot more, the solid, the precipitate will still remain there. That's why we say it's insoluble in excess. So you realize sodium hydroxide can help me to differentiate calcium from the zinc and lead ions. Okay, so based on what is being observed, you can know what the cations are. Okay, so white precipitate, whether it dissolves or don't dissolve in excess, it helps us to find out what cations are present. The next one will be the colored ions. Okay, so these are white on top, these three. Copper 2, iron 2, iron 3. So take note, the 2, 2, 3 are important. Okay, you need to know them, you need to write this down. So for copper, if I add sodium hydroxide initially, it will form a light blue precipitate. For iron 2, green precipitate, iron 3, reddish brown. So you realize the colors are very distinct. Okay, so if you see blue, confirm copper. You see green, confirm iron 2. You see reddish brown, confirm iron 3. Okay, you add excess, all of them are insoluble in excess. All. Okay, so this is the observation if you have copper 2, iron 2, or iron 3, okay, ions in a solution when you add sodium hydroxide to it. Last one will be ammonium cation. How to test for it? When you add sodium hydroxide initially, there's no precipitate. Okay, but when you warm it, ammonia gas is given off. Okay, ammonia gas is given off. And how do I know ammonia gas is given off? It's really because my moist red litmus paper turned blue. What exactly is happening here is really because this is actually an ammonium salt. So this is actually an alkali reaction. Ammonium salt plus alkali. What you're going to get is the salt plus ammonia. That's why you test for the ammonia gas plus water. So ammonium salt, the ammonium cation here, when it reacts alkali, it will give off the ammonia gas. So these 7 cations, by adding sodium hydroxide, you realize that you are able to differentiate almost all of them, except for zinc and lead. Because why? Both of them give you the similar reaction. Calcium is distinct, copper is distinct, iron 2, iron 3, and ammonium is distinct. That means you can differentiate this 5. Okay, you can differentiate this 5 from one another. But you have issues differentiating these 2. Okay, these 2, you can't differentiate because they have the same observation. So what to do next is really, let's use aqueous ammonia. Why? Let's take a look. Zinc, if I have zinc ion present in a solution, when I aqueous ammonia, you say, sure, white precipitate for zinc, white precipitate for lead when I initially add a few drops. Still cannot differentiate. Okay, so still cannot differentiate. Yes, you're right, if I just add a few drops. But if I add in excess, you realize, sure, I seem to see a little bit of difference over here. Why? Because for zinc, the precipitate will dissolve in excess to form a colorless solution. But my lead will be insoluble in excess. So realize, by using aqueous ammonia, I can finally differentiate between my zinc and my lead. Okay, I can differentiate between these 2. So that is why we need 2 different reagents here, okay, to differentiate, to identify cations itself. Of course, let's go through the rest. Calcium, this time around, no precipitate with aqueous ammonia. Of course, in excess, there's no precipitate as well. Copper 2, iron 2, iron 3, you realize the color of the precipitate is the same, except the difference really lies in copper 2. Now the precipitate will dissolve in excess and it forms a very nice deep blue solution. Iron 2, iron 3, the precipitate is still insoluble in excess. Okay, so this is the deep blue solution over here. Okay, there you see here. So this is for the copper 2. Okay, all the colors that you're supposed to see is over here. Okay, so your textbook actually has quite a good reference material for you to take note of. Okay, and for you to know how exactly the observations are. Of course, this is just a picture, but at least it gives you a good first cut on what we are expecting. Okay, so why do we actually get these precipitates? These precipitates that we actually get, okay, is actually the hydroxide of the metals. So if we add sodium hydroxide or aqueous ammonia to iron 3 ions, the reddish brown precipitate is actually iron 3 hydroxide. So take note, whenever you do a cation test, okay, the precipitates that's formed, these are hydroxides. Okay, it's just what is the metal that's present. So what metal hydroxide is it? Okay, why do they dissolve in excess? You don't really need to know too much in details, okay, but it's due to the formation of some other compounds, okay, when you add excess of this reagent. So just take note. Okay, so this is for cation. This is for cation. So you add sodium hydroxide or you add aqueous ammonia is a test for cation. Now, anion, how many do I need to remember? I only need to remember 4 of them. Okay, so good thing is that there's only 4 anions in my syllabus that I need to remember. Okay, the bad thing is each anion is a different test. Okay, I say again, each anion, although there are only 4 anions, but each anion is a different test. So how to test for carbonate? I actually add acid. Okay, need not be hydrochloric, can be other acid. So by adding acid, and then look out, okay, look out for effervescence. Effervescence means bubbling. Okay, so I add acid, I look out for bubbling. If the bubbling occurs, if effervescence is observed, and the gas forms white precipitate with lime water, I know it's carbonate. Because why? CO2 is produced. Because I know why? Carbonate, when I let it react acid, on an acid reaction, right? I'm going to get salt, water, plus carbon dioxide. So this react, sorry, not carbon, sorry, carbon dioxide. Okay, so what you realize is that I'm trying to use this reaction over here to test for carbonate. So if I add acid to a carbonate, if I add acid and if a carbonate is really present, I will get carbon dioxide gas. Okay, so that's how you test for carbonate. You add acid. Okay, you add acid to test for carbonate. Okay, the next one, I want to go through nitrate first. I want to go through sulfate and chloride. I think sulfate and chloride is quite easy. Okay, so now take note, sulfate and chloride. Let's do through sulfate first. You add dilute nitric acid. This acid here is actually just meant to make sure that carbonate is not present. Okay, so take note. But the main thing that tells you I'm testing for sulfate is really the word barium. So whenever you see the word barium being added and you're trying to test for an ion, the word barium is a giveaway. Because when you see the word barium nitrate or barium chloride being used, you're trying to test for the sulfate. So the word barium nitrate solution is really the test for your sulfate ions. How do I know sulfate is present? The white precipitate of barium sulfate is formed. Okay, so what I'm going to do, I add barium nitrate to the solution. If I see a white precipitate, that means sulfate is present. Okay, same logic over here for the chloride. I add nitric acid first. It's just to make sure that there's no carbonate present. Then I add the silver nitrate solution. So the key word here to tell you that I'm testing for chloride is actually the word silver. Silver is to tell you that I'm trying to test for chloride. You realize, how come also white precipitate? Take note, this is white precipitate of silver chloride. Okay, although sulfate test, chloride test, both are white precipitate that I'm trying to observe, but the two precipitates are different precipitates. This white precipitate here is barium sulfate because I added barium to sulfate. This white precipitate here is actually silver chloride because I added silver to the chloride solution. Okay, and lastly, I got nitrate. Nitrate is a bit more complex. You got to add two things. What are the two things? Sodium hydroxide and aluminum foil. You got to add both together and then you warm it up. So there's actually 3 steps here. Add sodium hydroxide, add aluminum foil, and then you warm it up. Okay, these 3 things after you added, what do you want to look out for? You are trying to look out for effervescence once again. So you're trying to look out for this effervescence. Now, effervescence just tells you that gas is produced. Okay, but what is the gas I'm trying to look out for? It's different from a carbonate here. Okay, the gas I'm trying to look out for is ammonia gas. And how do I test? I use a moist red litmus paper and it must turn blue. Okay, so these are my 4 anions tests and the results. Okay, if you're able to know the cation test, anion test, okay, more or less you're quite safe already. Okay, the gas test for gas, you can go and read out on your own. Okay, I won't go through so much in detail here. Okay, because I think it is quite easy to understand itself. What I'll do is actually for this last part of salts, I would like us to look at some examples of how to go about doing it. Okay, so this is the typical combined science questions that like to come out, and normally is worth quite a fair bit of marks. So let's look at it. Okay, figure shows a reaction of substance A. So A is over here. So what are the reactions? So how to understand this diagram? A, I add sodium hydroxide. A, I add dilute nitric acid, then silver nitrate. Okay, so these are two different reactions that's happening here. So let's do step by step. Let's look at one first. A adds sodium hydroxide. I get white precipitate, insoluble in excess. So first thing, you need to know what is happening at the step. So when I add aqueous sodium hydroxide, you say, sure, this is QA, this thing is QA itself. I will either test for cation or I will test for an ion. Sodium hydroxide alone, if I just add aqueous sodium hydroxide, actually this is a cation test. This is a test for cation. So once I know it's a test for cation, I will look out for the color of the precipitate. I will look out for whether it's soluble or insoluble in excess. So sodium hydroxide, test for cation. White precipitate, insoluble in excess. They say, sure, how do I know what is it? You refer back to the table. Okay, so I know it's at sodium hydroxide over here. White precipitate only is zinc, lead, or calcium. So white precipitate here. Insoluble in excess tells me that it's calcium because zinc and lead do not, zinc and lead dissolves in excess. Only calcium does not dissolve in excess. Therefore, I know C, this precipitate over here will be calcium hydroxide. They say, sure, how do you know it's hydroxide? Okay, I mentioned already. Okay, so we can go back down here. Take note. They mentioned here is that the precipitate that's formed is the hydroxide of the metal or the hydroxide of the cation. So therefore, whenever you got test for cation, the precipitate will always be a hydroxide. So take note, okay? So I know C is calcium hydroxide because of the white precipitate over there. Say, good job. Now, then of course the question is, sure, so what if I know C is calcium hydroxide? So what if I know C is calcium hydroxide? So what? Now, this is the part here. You cannot just stop here and just say calcium hydroxide. Now, what is happening here is that when you do this, adding sodium hydroxide, you're testing for the cation. Where did the cation come from? The cation come from solution A. So therefore, one thing I know is this. If I test for cation, if I test for the cation in solution A, I got calcium hydroxide. It tells me that A contains calcium. Okay, you must be drawing that link because I test what is in A. I test what's the cation in A. I know calcium hydroxide is formed. So calcium must be present in A. Okay, next one. I add dilute nitric acid. This one test for carbonate. No, must read finish. I add silver nitrate. When you see the word silver, I know I'm trying to test for chloride. Okay? White precipitate is formed. Remember, if I add silver nitrate, I get a white precipitate. What is the white precipitate that's formed? Chloride, add silver nitrate, a white precipitate of silver chloride is formed. So I know B is silver chloride. So as mentioned, okay, this reaction here is to test for chloride. Test for chloride in A. And you know that silver chloride is formed. It tells you that A actually contains chloride. So therefore, B is silver chloride. A is calcium chloride. So all this annotation at the top is very important. Okay, I'm going to go slow again. Okay, part B, I'm just going to ignore. Okay, typically this will come out for the exams and stuff, but I don't want to go through this ionic equation part here. You can go through a little bit more in detail in the future. Okay, the next one I want to look at is question 2. You realize I put a similar pattern together again. Okay, so first thing you do is not to jump straight into identifying what ABC is. Always ask yourself what is happening in each of the reactions. So for the first one over here, I add aqueous ammonia. You know, aqueous ammonia, this is a test for cation. On this side over here, I add nitric acid. Test for carbonate. No. Wait, read, finish everything. Okay, so you got barium nitrate solution. So dilute nitric acid and barium nitrate. You see the word barium here? You know that this is a test for sulfate. Okay, so let's do step by step. Number 1 first. Add aqueous ammonia. I got white precipitate form. I got B, soluble in excess. So let's go back to our table. Let's go back to our table over here. Aqueous ammonia. So aqueous ammonia here. White precipitate form. Okay, I know it's either zinc or lead. Dissolve, okay, in excess. The only one that can dissolve in excess over here is zinc. So if I go back to this worksheet, I know that C will be zinc hydroxide. Okay, the precipitate that dissolves in excess is zinc hydroxide. Then, so the question you ask is, I'm testing for cation in A. C is zinc hydroxide. So what does it mean? It means that A must have contained the cation zinc. Okay? But what exactly is in A? A is not zinc alone. A is zinc something. Now, what is that something? Okay, that's why we're going to do step 2 now. Step 2, we are doing a test for sulfate. White precipitate is formed. Good job. So white precipitate is formed, which means that if I scroll down to test for anion, white precipitate of barium sulfate is formed. So B is barium sulfate. This white precipitate here is barium sulfate. So based on this, I know that sulfate is present in A. Therefore, A must be zinc sulfate. So let's finish up. B, I know is barium sulfate. A is zinc sulfate. Okay, so these 2 examples will be good enough to let you know how you can do the test for cation, test for anion itself. Okay, so this worksheet, okay, is made available, okay, to you by your teachers. So do request for this worksheet, this salts worksheet part 2 extra. Okay, there's a lot of questions here, okay, for you to really look through, for you to practice. And with the practices, it's going to help you a lot. Okay, it's going to help you a lot to be able to do these QA questions. Okay, so go and look through the questions and then find out what the answers are. Okay, so that's all for this salt. If you're able to do the QA, you're more or less fine itself. Okay, so that's all.